Hello class, Professor Anderson here. Let's try an example of a problem looking at polar coordinates for a simple set of coordinates. And let's start with x equals -3, y equals 4, and let's ask the question, what is r and what is theta? All right, so xy being -3, 4 means we are in a particular quadrant here. And if we mark off x equals -3, that would be 1, 2, 3. And y equals 4, 1, 2, 3, 4. So where those two lines intersect, that's the point that we're interested in, right there. Okay, that is -3, 4. All right, and now we're faced with the question, what is r and what is theta? Well, r is, of course, how far are you from the origin? So that is r. What is theta? Theta is how far are you around from the x-axis. So theta, in our case, looks like that. All right, now what do we do? Well, I think we can go back to our trig relations and figure out how r and theta relate to this particular x and y. And let's redraw this triangle to visualize that. Okay, I've taken this triangle right here and I've redrawn it right there. The hypotenuse of the triangle is r. The bottom of the triangle has a magnitude of 3. We know it's negative, but it has a magnitude of 3. And we know that the vertical side is 4. So, what does r have to be equal to? Anybody heard of a right triangle that starts with a 3 and then goes to a 4? What's the third side equal to? Anybody know that one? Yeah?
5.
5. It's a 3, 4, 5 triangle. Okay, that's one of those special right triangles. Let's just convince ourselves that that is true. R is equal to the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16. 9 plus 16 is equal to 25, and the square root of 25 is, of course, 5. Okay. Now, if I had put a -3 right there, would it change anything? No, because we'd be squaring that whole quantity. All right? So -3 squared is the exact same as 3 squared. We end up with the same answer. Now let's think about theta. Theta in this picture is a large angle. It's bigger than 90 degrees. And that doesn't really map very nicely to our triangle anywhere. But we could probably say something about that angle right there. And then what we can say is the rest of the angle is theta. And so right off the bat, we know that phi plus theta has to equal 180 degrees. Okay, phi plus theta is equal to 180 degrees. If we can determine what phi is, then we know exactly what theta is. So let's look at this triangle again. And what should I use to calculate phi? What do you guys think? Do I need to use sine? Do I need to use cosine? Do I need to use tangent? Or could I use any of them? Yeah, what do you think?
You could use any of them.
Why can I use any of them?
Because it's just either like opposite over adjacent or hypotenuse over adjacent.
Exactly, and in fact, we now know all sides of that triangle.
Yeah.
So if you know all sides of the triangle, then you can use any of those, right? So which one do you like?
I guess cosine of phi.
Cosine, excellent choice. Cosine of theta. In this case, cosine of theta is what? Well, we're doing phi. Cosine of phi is what? Well, phi is this little angle right here. So cosine is going to be adjacent which is 3, divided by the hypotenuse r, which we said was 5. All right, so you can plug this into your calculator, take the arc cosine of 3 over 5, and what do you get? Anybody have their calculator with them?
53.1 degrees.
53.1 degrees. All right, let's just call that 53 degrees. And if that angle is 53 degrees, then what does theta have to be? Theta is, of course, 180 minus that phi. 180 minus phi is 180 minus 53, and we get 127 degrees. Okay, hopefully that one is clear. If you have any questions about it, come see me in office hours. Cheers.